Hi everyone, in this recording we'll introduce the idea of scales and apply them to visualize the Gapminder dataset. So at the end we'll have this interactive visualization. On the x-axis is the log population size, the y-axis is the life expectancy, the colors correspond to different continents. I haven't labeled the axis just to keep the code relatively simple. The cool thing is you can slide around, and these are going to be different years. So this is the most recent year, this is 1965, and we can select all the different continents. Right? So you're going to be able to see the differential changes across different continents just by sliding around. Something that's really neat in this that you could never achieve in Shiny is that we do get smooth transitions. Right? If we used a slider and a plot output in Shiny, it would just be flashing from one version to the next. But here we get something smooth. Okay, before we do anything interactive, let's think about how we would make this for a single time point and single subset of countries. The thing we're going to need is a scale. So a scale together with adders functions, this is how we do encodings in D3. It takes some property of the dataset and maps it to some property of the graphical marks. There are lots and lots of different scales available in D3, but they all have this kind of typical structure. So you're going to have the name of the scale here. And then you're going to map from a whole bunch of domain data values to a range of what are the properties of the graphical marks that we're making. So just as like a toy example, if you used an ordinal scale, so in D3 that would be called scale ordinal, you could give it a whole bunch of categories. Here are just city names, and you can give it a range. Here the range is mapping to different colors. And now if I called this name scale object like it were a function, then it's going to map all these domains into the range. So looking back at this visualization, what kind of scales do we need? We need a scale for the color, so mapping each of the different groups. We're going to need a scale for the x value, which is the log population size, and y, the life expectancy. So there are three different kinds of scales. Right? The x and y axis, these are going to just be linear quantitative scales, and we're going to need a color mapping that's similar to this ordinal scale here. So first, let's find the domains, right? So for life expectancy, we need to give it an array of length 2, and it needs to start with the lowest possible life expectancy that we might encode, and then the highest one that we want to encode. We can do this by using d3.extent. d3.extent will take a long array and will collapse it to just the minimum and the maximum values. So this is extracting just the life expectancy values from across all my objects, and I'm getting the min and max values. I can plug that in as my domain, and now I set my range 500, 0. So this might be opposite of what you were expecting. Right? You might be thinking, like, shouldn't the lowest life expectancy be mapped to 0 and the highest to 500? The thing is, when you use SVG, 0 corresponds to the top left corner. 500 would be the bottom, right? So I'm actually saying the very high life expectancies, I want that to be near the 0, and the very low life expectancies, I want that to be near the 500. So that's why I've ordered it that way. Okay, so that's how you would do it for all the linear scales. For the color scale, we need something a little bit different. We're not just looking at the min and max of some continuous values. We need all the unique values that appear in the array. So this is just the syntax in JavaScript for getting the unique values. It's a little bit unusual, but the main idea is you just take whatever complicated array, you convert it to a set. A set is going to only include the unique values. And once you have that set, you can convert it back to an array. And that's what this ... array notation does. Okay, so I'm extracting all the continents. This is a long, long array of all the continent names for every single country. And then I'm getting the unique ones. I plug that in as my domain, and as my color, I'm using this scheme set2 object. It comes directly in D3. I'm getting it from the color library. You can follow this link and see a whole bunch of different color ranges. But from here, I now have all the scales that I need to encode the raw data into attributes of my visual marks. A thing that I tend to do, it's not universal, but I'd like to store all my scales in one object. So if I store them all in one object, I can access them a little bit more conveniently than I think if I were to have many different variables for every single scale. Okay, so now that we have the scales, let's start making the visualization. So the first thing I'm going to do here, I'm just taking all the raw data. I'm picking only 1965, so the very first year in the dataset, and I'm entering them and encoding the circle's position and color using my scales, the ones that I just created. So this is going to enter all those circle tags on the HTML, and it's going to set their attributes according to the scales. Okay, so this would be enough for a static visualization, but let's try to think about how we would do some sort of interaction. We're going to need something with the general update pattern. So what are the kinds of updates we might need? If the user has selected a different set of continents, we're going to need to enter and exit circles, right? If a new continent appears, we need to enter all the countries associated with that continent. On the other hand, if they move the slider, we show the exact same circles, so there is no entering or exiting, but we need to change the encoding. We need to change the X and Y positions to reflect the new locations for that year. So let's do one step at a time. Let's think about how we would exit and enter the countries. So there's some array called continents, and it's showing at the beginning, it's showing all the continents that are available, but when the user is clicking on different of the selection menus, it's changing this array. So it's going to reduce it down to only the ones that the user has selected. So we'll talk about how that interaction does in a future lecture, but for now, just trust every time these selection menu options are changed, this continents array is changed. So if that continents array is changed, then I can filter my data according to whether the data's continent is contained among the selected ones. This index of notation, what it means is it's going to look within this continents array. It's going to look for whether the current data's continent is contained within this array. If it's contained within that array, it's going to give the index of where it's located in that array. But if it's not contained in the array at all, so like if right now only Americas and Europe is selected, but then I gave it Africa, it's not going to be found within that length to array. So it's going to return an index of -1. So that's how you can filter according to some array. Now that I've filtered, right, I can just go and update my selections, right? So here's the original data bind. I'm taking all the circles are going to be associated with one country. The way I make sure that it's associated with a country is I use an ID function, just like in the previous lecture. So I have the country ID. I enter if a new continent has appeared and a whole bunch of new countries associated with that continent have appeared. I'm going to enter them and set their attributes. If a whole bunch of countries have been removed because that continent has been removed, I'm going to take that exit selection and remove them. So that is how the country selections were changed. If you click this link, you're going to get a link to the HTML and the JavaScript that's only doing just the country updates. So nothing with the year, nothing with the slider, but it will allow you to select and enter and exit those countries. Okay, so what about the years? So if I want to extend it so that I can do the sliding with the year, I now am assuming that there's some year variable that is being updated by the slider. And again, don't worry about how the interaction works because we'll have a whole week discussing interaction. But just assume that whenever I move that slider, it's changing this variable called year. So in the same way that I could filter the data according to the continent, I can filter the data according to the year. So that's what's going on here. The current subset is the data, but filtered to the current continents and the current year. Now, I can again bind the data. And now, whenever I change that slider, I don't need to enter or exit anything. So those are all the same. But I need to transition it. I need to transition the locations according to the new populations and the new life expectancies associated with the new year. All right. So this is what's creating that smooth transition every time I move the slider. So that's it. It looks a little bit complicated if you can follow the full code here. It's 70 lines for a kind of scatter plot, so that seems like a bit much. But it's giving a very smooth kind of interactivity, and it's allowing several kinds of queries. So it's eventually gets kind of, you get kind of used to it. Also, the patterns end up being very, very similar. You're always going to be having these enters, exits, and updates. And to encode the data, we just need to make sure to use scales.